Okay, so I said I would do an example of the method of partial fractions involving long division. So let's get started. Okay, so what we notice here is that we have degree in the numerator is 3, and then the denominator is 2. And in fact, the denominator isn't even factored. But the first thing, once we notice that the degree of the numerator is larger than the degree of the denominator, then we automatically can go through long division. Okay, we will take care of the fact or deal with the fact that it's not factored in a minute. But for now, we'll do long division. And so we will have the divisor here, and then this is our dividend. All right, so a review of long division. And if you want to put in 0 as a placeholder for a term, because we don't have a constant term here, you can. Still, some students find it useful to do that. And here, even in x to the third plus 1, you may want to put in placeholders for the x squared and the x term. You don't have to, but it can help in terms of organizing. Okay. And so the process, you may remember, the process for long division is you look at the first term of your divisor, the first term in your dividend. Reading from left to right, you think x squared times what will give me x cubed. And we see that that will be x. And so I line that up with the x. And then you take this term and distribute and multiply it through to each term here in your divisor. And we get, this is the division algorithm. So x cubed minus 4x squared plus 0x. We subtract and then we add straight down. So that cancels off the x cubes. And we'll end up with 4x squared still plus 0x. And then we bring down the 1 because usually the same number of terms in your divisor, you have that there. You continue the algorithm until this term is strictly less than the term in your divisor. Okay, if it's greater or the same, that means you can keep using this algorithm. And so since it's the same, we now say, well, x squared times what will give me 4x squared, and that will be 4. Then distribute that 4 to each of those terms. So 4x squared minus 16x plus 0. Subtract and add down. That will cancel off. We get 16x plus 1. Now this degree is less than the degree in the divisor. So this becomes our remainder. And up here is our quotient. All right. And so when you look at this, x cubed plus 1 over x squared minus 4x, it's going to equal your quotient plus the remainder, but you put your remainder over the divisor. So x squared minus 4x. I'm going to take off the 0 now. In terms of thinking about, okay, our goal is to integrate, right? Well, the terms of our quotient, we can just integrate those directly. So now we need to do a PFD on whatever your remainder is. Okay. Now I'll say this, sometimes when you're doing long division, if there is no remainder, then that means you just have your quotient here and you just integrate directly. So there may be a case where if you use long division, you may not need to use the method of partial fractions. We will in this case because we have this remainder here and we need to evaluate that, right? But there could be some cases where that is not needed, okay? Okay, so now just looking at this, looking at the PFD, well, first let's factor. Now we should factor that denominator. And that'll tell us, well, which case is this? Well, this is just distinct linear factors. So the setup would be 16x plus 1 over x times x minus 4 equals a over x plus b over x minus 4. I need to make sure you show this setup in your work. This is very important. Okay, don't skip steps on this setup. I need to see this initial setup in your work. Okay. Well, now we can clear fractions. So 16x plus 1 equals a times x minus 4 plus b times x. Whenever you have the case with just distinct linear factors, so not the repeated case, you have the exact number of zeros or solutions as constants. So the first method just makes sense. Of course, you can always do the second method too, but it just makes sense in terms of efficiency to use this first method because we're going to just right away solve for our constants. So when x is equal to 0, what will we have? The left-hand side will equal 1, and the right-hand side will equal negative 4a, right? So a equals negative 1/4. So you should pause the video and look to see what happens when x equals 4. Welcome back, and you ended up with b equaling 65/4. So very good. So now we put everything together, and I always like to go back to our original integral equals the integral. Remember our quotient. Don't forget about that x plus 4, but then plus negative 1/4 over x plus 65 over 4 over x minus 4 dx. We break these up separately. The integral of x dx, the integral of 4 dx, minus 1/4 the integral of 1 over x dx, plus 65/4 the integral of 1 over x minus 4 dx. Thus, our final answer will be x squared over 2 plus 4x minus 1/4 times the natural log of x, absolute value of x, plus 65/4 times the natural log of x minus 4 plus c. Okay, I hope that made sense. See you in class.